This is Geometry, section 10.1, areas of triangles and parallelograms. So we're going to start with something a little bit easier than triangles and parallelograms, the area of a rectangle. So rectangle looks like this. We've got 4 right angles. You probably know to find the area of a rectangle, we're going to take whatever the base is times whatever the height is, or sometimes those lengths are called the width and the height, or width and length. So to do that, we would just, let's say the base was 6, the height was 4. We would just multiply those two together, so the area of this rectangle would be 4 times 6, or 24, and it's going to be whatever our units are, it's going to be those units squared, so square feet, square inches, etc. Okay, so a square, if a square is just a special kind of rectangle, then it's got the base and the height would be the same thing. So 4 times 4 would just be 16 square units, or units squared, or just whatever your side length is, because all the sides are the same, whatever the side length is squared. Okay. So a little bit more complicated. If we take a rectangle and sort of slant it, we know that that shape is called a parallelogram. So we've got, still we have a base, and the formula for the area of a parallelogram is actually going to be the same thing as the area of a rectangle. It's going to be the base times the height. However, this is not my height for a parallelogram because this is going diagonally. That's what a parallelogram is. It's kind of a slanted rectangle. So our height is still going to go from straight from the top to the bottom, and it's got to be perpendicular to the top and the bottom. So it's not just whatever the two sides are multiplied together. We have to figure out what this height is somehow. It's not always going to be given to us. Sometimes we're going to have to find it. Okay, so here we've got a parallelogram, and it says to find h. Well, there's some weird stuff drawn in here. So the regular parallelogram are these solid lines right here. That's our parallelogram. Notice that we've got this side, which is 12, which means this side also has to be 12. This side is 6, which means this side is also 6. So if we use this as our base, then it gives us our height right here, which is 4. So the area of the parallelogram would just be 4 times 12, or 48. So that's the area of the parallelogram. But it says to find h. This piece right here is labeled h. So if we sort of flip the parallelogram, which isn't that easy to do on this video, but in class, when we do this in class, you can actually flip your paper. If we flip it so that it looks like this, so the 6 is right here, and the 12s are here and here, then if I redraw out these dotted lines, it's really just going like this. H would be here, and then this is just an extra dotted line. So what that's really saying is, okay, if I flip it the other way, and now this is my base, what's the height going this way? Well, we already know the area is base times height, and we already figured out the area was 48 by using the 12 and the 4. So we know the area has to be 48. So if we substitute in the value that we have for these, we know the base is 6. So 6 times what, or 6 times h, we're trying to find h, is going to give me 48. So to find that, I would just divide both sides by 6, and 8 would be our h. All right, areas of triangles. So that was areas of parallelograms. Area of a parallelogram is just base times height, but sometimes we have to find the height. Area of a triangle, we started with a rectangle. We said it was base times height for the area. If I split this rectangle in half, what shape do I have? Well, I have 2 triangles, 1 and 2. So the area of a rectangle is just going to be 1/2, because this is half of the rectangle. If I cut it in half like this, then I have 2 triangles. The area of a triangle is going to be 1/2 times whatever its base is times whatever its height is. So this would be the, this would be the base of the triangle. This would be the height of the triangle. We know if we multiply those together, we get the area of the entire rectangle, but I only want half of that area. So that's where the 1/2 comes from. So how do we calculate the area of a triangle? 1/2 times its base. Area of a triangle is 1/2 times its base times its height. Just like with a parallelogram, the base and the height have to be perpendicular to each other. Perpendicular. So the height must be drawn perpendicular to the base. Okay. All right, so the area of two triangles. Let's put this into a real example. So first I'm going to draw an isosceles triangle. Each of these sides are going to be 5, and this bottom side is going to be 6. We'll come back to that one. Then I'm going to draw an obtuse triangle. So I'm going to draw a triangle with an obtuse angle in it like this. And I'm going to draw in this piece. Make sure that this is a dotted line. So this piece of the dotted line is going to be 6. This piece right here is going to be 10. And this piece right here, these are going to be congruent. This is also going to be 10. Okay, so we've got an isosceles acute triangle and an isosceles obtuse triangle. So we've got 6 here, 10 here, 10 here. These are each 5, and this is 6. So we need to find the area of both of these triangles. Well, it says the area is 1/2 times the base times the height. We don't have a height for either of these triangles. So what we can do with this one is, since it's isosceles, I can just call this my base. And if I split this in half, then each of these pieces is 3. So this is now 3, this is now 3. To find this length, which is my height, so my base is still 6, even though I cut it into 2 pieces of 3. So my base is 6, so we might want to write that out to keep that straight. To figure out the height, now we've got 2 right triangles next to each other. So to figure out this missing piece, I can just use the Pythagorean theorem. So it would be a squared, b squared, and c squared. 5 would be the hypotenuse, so I have to set it up like this. 3 squared plus x squared, or you can use h if you want since it's the height, equals 5 squared. 3 squared is 9, x squared, 5 squared is 25. We would subtract this from both sides, so x squared would equal 16. When I square root that, this would be 4. So my height would be 4. So I would take 1/2 times the base times the height. 1/2 of 6 is 3, and then 3 times 4 is 12. You only multiply the 1/2 once. You're not distributing, you're just multiplying these 3 numbers together. So don't take 1/2 of 6 and 1/2 of 4. You only take 1/2 of one of them and then multiply it by the other one. Or you could just type the whole thing in your calculator and it would give you the right answer. 1/2 times 6 times 4. So we've got 12 there. For this one, this dotted line right here would be our height. This bottom side would be our base. The base would not be these 2 sides added together. It would not be that. It's only whatever is part of the triangle. So this would be our base. That's the bottom. And we can find this height, same thing, Pythagorean theorem for the height going this way from top to bottom. So to do that, we could use Pythagorean theorem again. 10 would be the hypotenuse, so 10 squared equals the other 2 squared. This is 36. This is 100. Subtract 36 from both sides. This is 64. And then when we square root that, we get that this is 8. So my height would be 8. My base was 10. So again, 1/2 times base times height. 1/2 of 10 is 5, and 5 times 8 is 40. Okay. All right, so just make sure that you're always finding your base and your height, and those 2 things are perpendicular to each other. So even though this base isn't touching this height, we just extended this line out this way so that it's still measuring straight from the top of the triangle, which is right here, to that base, where that base would go. All right, last thing, if 2 triangles are similar, what can we say about their areas? So let's just use an example. Triangle that we're familiar with is 3, 4, a 3, 4, 5 triangle. That's a Pythagorean triple. If we make that 2 times bigger, so let's make everything bigger, similar, we'll use a scale factor of 2. So 3 would turn into 6, 4 would turn into 8, 5 would turn into 10. Okay, so to calculate the area of these triangles, first of all, our scale factor was 2. Okay, so we made everything 2 times bigger. So let's calculate the area of both of these triangles. 1/2 times the base times the height. Well, luckily we got a right angle here. This is our base, 4. This is our height, 3. Same thing over here. Our base is 8. Our height is 6. So 1/2 times 4 times 3. 4 times 3 is 12. Half of that is 6. 8 times 6 is 48. Half of that is 24. Well, our scale factor was 2. We made everything 2 times bigger, but the area got bigger by more than a factor of 2. 6 times 2 would have been 12. So this was the starting area. You would think the ending area would be 12. Actually, what happened here is we took our scale factor and we squared it. So if we had made everything 3 times bigger, if our scale factor was 3, then 3 squared would be 9, and the area would have gotten 9 times bigger. So 2 squared is 4. The area got 4 times bigger. If we used a scale factor of 4, so if I turned 3 into 12 and 4 into 16, then our entire area would have gotten bigger by a factor of 4 squared, or 16. Our area would have been 16 times bigger. So for similar triangles, you take the scale factor and you square it to figure out how much bigger the area becomes, or how much smaller it becomes as well. If we did 1/2 squared would be 1 over 4, because 1 squared is 1, 2 squared is 2. So the area would have been only 1/4 as big. So you take your scale factor and you square it to figure out the comparison of the area.